Good afternoon, everyone. Hope you're all having fun at re:Invent. Thank you for joining the session today. My name is Prahlad Rao. I'm a solutions architect at Amazon Web Services. The session today is cross-region replication with Amazon DynamoDB streams. We also have today with us Carl Youngblood from Under Armour, who will speak about their implementation of DynamoDB. So just a show of hands, how many of you are already using DynamoDB today? Great. OK. So the goal of this session today is to provide best practice and useful guidance from a customer implementation of DynamoDB. And hopefully, by the end of the session, you'll be able to take actionable guidance for your own deployment of DynamoDB within your environments. We'll begin with a quick recap of DynamoDB, look at its features and capabilities, and then we'll review some of the DynamoDB patterns, replication patterns, and use cases, and what tools that Amazon provides today that allow you to replicate data sets within DynamoDB. We'll then have Carl from Under Armour come on stage to talk about their implementation of DynamoDB, review their use case, look at the decision process they went through in understanding what they have the solution today, some of the experience, lessons learned, and next steps. Amazon DynamoDB provides a fully managed NoSQL database experience that alleviates the need for you to maintain and manage the underlying infrastructure required to run NoSQL databases. With a simple clicks or API calls, and by specifying the necessary read and write capacity units, you can easily get started in leveraging DynamoDB as a NoSQL solution for your application environments. DynamoDB is designed to scale to any workload and provides low single-digit millisecond latency for your application access. In addition, DynamoDB also provides rich capabilities around access and authentication control for your tables through IAM and fine-grained access control that allow you to granularly manage permissions on a per table or per row basis within the DynamoDB table data structure. For those of you coming in from the SQL world, a table is similar to what we have table in a SQL world. So you have table, you have rows, and columns. In a NoSQL database, you still have the construct of table, and within table, you have what we call as items that are essentially rows, and each item comprises of attributes that are essentially key value pairs. All you need is a hash key to get started in creating a table and leveraging that. In addition to that, through a combination of hash key, range key, and/or global and local secondary indexes, that provides rich query capabilities for you to model a one-to-one, one-to-n, or end-to-end relationships within your data sets. Any data that is written to a DynamoDB table is replicated across multiple availability zones in a region. Partitions allow you to scale your data sets within a DynamoDB table horizontally across multiple nodes in the backend. And you, as a customer, since the partitions and the replication mechanism is inherently provided by the DynamoDB service, you don't have to maintain and manage the partitions and the replication mechanism in order to leverage these capabilities. So why do you want to replicate data sets within a DynamoDB table when we already provide the capability to replicate data across AZs data across multiple AZs in a region? Well, you might have globally distributed applications that need access to low latency data sets that are residing in DynamoDB table for your applications. Traffic distribution, that means you might have applications across different regions worldwide where your users would require low latency access to that application and data set based on their location. And then, of course, disaster recovery. In case you need to maintain an additional copy of your data set over and on top of what we provide as data redundancy capability. You can easily copy the data set to a different region as a backup copy. There's another thing that's probably not mentioned here is also for compliance reason. You might have a need to maybe copy data or maintain different data sets across regions for compliance and security reasons as well. The primary mechanism of leveraging replication within DynamoDB is accomplished through streams, DynamoDB streams. Streams provides or captures the continuous updates that are made to a table, whether it's add, modify, delete record to the primary table, and captures all the changes that are made to the table and provides that as a stream of data to end users. And these are strictly ordered. That means that allow you to easily take advantage of applications that require strict ordering capability. In addition, the data within the streams are available up to 24-hour timeline, in which case your downstream applications can easily use the streams data and to leverage that as additional workflows or maybe additional triggers for your applications. So in the context of replication, we have in-region replication and cross-region replication. In-region replication, as I mentioned, the service natively provides automatic replication. That means you don't have to do anything. You create a table, add data, add records to the table, and there you go. The data is already available across multiple AZs, and these are mainly meant for data production and redundancy. However, there might be a need for users to maintain an additional backup copy or a copy to be used for maybe a secondary application. They don't want to use the primary table for their application, for the secondary application, in which case you can easily accomplish data replication through a combination of DynamoDB streams and AWS Lambda functionality to copy data from one table to another table within the same region. So by way of AWS Lambda, Lambda can easily invoke or trigger based on the updates that are made to the primary table. In order for our customers to easily set up cross-region replication for DynamoDB, we have made available a cross-region replication library that uses a combination of DynamoDB streams and Kinesis client library to set up a replication solution to copy data across regions. The replication library is available in our GitHub repository, and we welcome feedback to the going in a little bit details on how the cross-region replication library solution is by way of setting up a Kinesis client library application on an EC2 instance, and then when you enable DynamoDB streams to your primary table, the DynamoDB client writes to the primary table, and the updates are captured through the streams. And then by way of the Kinesis client library, when you set up, it sets up based on the number of partitions that you already have within DynamoDB to create the Kinesis client library worker nodes or worker instances, right? So the KCL worker is responsible for replicating data from your primary table to a secondary table across different regions. However, in order to use and leverage the Kinesis client library or the cross-region replication library I mentioned, you need to set up an EC2 instance, set up the Kinesis client library on top of it, and then enable replication. Through a combination of DynamoDB streams and AWS Lambda functionality, you can create an event-driven architecture where the streams are constantly captured and invoked by Lambda functions so that the Lambda function that you write can copy the data from your table to a different table across regions. So this provides you to take advantage of the powerful capabilities of our Lambda service without having to maintain and manage an EC2 instance, set up all the Kinesis client library worker instances. With that introduction, I now invite Carl from Under Armour to take us through the next set of the presentation slides. Thank you. Welcome, Carl.
Thank you. Thank you. So one thing I want to make clear is Parla did not lie. I do work for Under Armour. That's true. But also, this is a high-level talk. So I'm not going to do a really deep dive on a particular technical topic. I'm going to walk you through, like we talked about on the second slide, I'm going to walk you through our experience, and I hope that something will jump out at you as a hook that is similar to your own experience or your own plans that you can follow up on. So we're going to touch on a few different topics over the next over the next 40 or so slides, the next 40 or so minutes. So the first thing we're going to talk about is just some context building and some background, right? So Under Armour, depending on who you've worked for, your experience may seem like a big company. This is Kevin Plank, our CEO, giving a talk to a fraction of the company. We have offices across the globe, and this map is actually out of date already. We have an office in San Francisco for sure now. So we're growing, but I work for a very particular part of Under Armour, which is Under Armour Connected Fitness. So Connected Fitness are the engineers who build and maintain some apps you may or may not be familiar with. Those apps are things like MyFitnessPal, MapMyFitness, Endomondo, UA Record, and UA Shop, right? So they're these mobile apps and web applications that you can use to do different things like log foods or log workouts. We're kind of spread out. There's a lot of us in Austin and there's a lot of us in San Francisco, but there's also a fair group in Copenhagen and Denver, and then kind of this long tail. So we're a pretty diverse group. There was an about me slide in the template, so I was going to fill it out originally with like kind of boring stuff about my actual title at Under Armour, and that's not really important. So I put pictures up that kind of represent me as a person. And so, I'm the kind of person who takes greens that are called power greens, and I work out in my garage and I have Halloween dogs. The bottom right is a little bit relevant. That's the Austin office. It's a little bit less cartoony in real life. This is like concept art from before it was built. I am based in Austin, so howdy y'all. This is where I work, and this is like, I think it was 40% from that pie chart of the UACF Under Armour Connected Fitness engineers are based here. So, hang on, click. So, single sign-on, what does it mean? Why am I talking about this? It's not cross-region replication. Well, it's a little bit of background. Let's burn through it real quick, right? So that the rest of the talk makes sense. So single sign-on can mean a lot of different things in different contexts. There's like enterprise single sign-on, right? That's not what I'm talking about. This single sign-on is specific to those apps I listed that Under Armour builds and maintains. So it's the ability to move from MyFitnessPal to MapMyFitness without having to re-enter your credentials, right? So that's the definition for this talk, just to make that real clear. These next slides are entirely visual, just for people who like to see pictures, like the visual part of the audience. They're just screenshots from a mobile device, right? This is walking through the single sign-on experience. So for example, you open UA shop going left to right along this slide. You fill out your initial information about preferences, and you find something that you're going to add to your cart. I broke the clicker. So you've added this item to your cart, and you have to log in to check out, and so it asks for your credentials, right? That is the vanilla flow. So let's take a step back, kind of like reset your mind now, right? This is a different app on the same phone. You've installed and you're logging into UA record, right? So there's nothing special about this in particular, this slide, other than demonstrating that I'm entering my credentials and I log in. You can see my profile pic in the upper left, right? So if we go back and we kind of like rewind the timeline, and we're back in UA shop, except this time we're already signed into UA record. This time when we add that item to our cart and we go to checkout, UA shop can recognize us, and it can say, hey, Carl, continue as yourself, or if not, you can click the little link. But there's no reason our users should have to go through the typing in your password again. And then this is actually just kind of an array of 3 different apps. Actually, you've seen 2 of them. It's MapMyFitness from the left, UA record in the middle, and UA shop on the right. Just demonstrating that it's me logged into all of them. It's the same profile picture, right? It's the same user. So it's multiple apps and one identity service on the back end. And I'm going to try to play a video. But it's really not important. This video is literally just an animated version of those slides. So let's move on. OK, so that single sign-on. So now we know what that word means. Now we know what that word means, and we kind of have like seen it in action, right? So I think it's like 12 to 18 months. It's a pretty broad range, I know. But between 12 and 18 months ago, we said we're going to build single sign-on. That was the goal, what you just saw, right? We were driving towards that. So we knew we needed an OpenID application. We needed an identity service. And so that was the work. That's the team that I was on, and that's the work that led to our need for cross-region replication. So now we're kind of getting to the actual, talk topic, right? But our choice of tooling, you get a different one. That's cool. I'm going to uncomfortably reach around you and hit that. So there's some context, though, about our choice of tooling. Like, why did we even end up on DynamoDB? Well, we started with 3 people, and our max team size really ended up at 4. So we were a pretty small team for this. And this goal, again, just to reiterate, 180 million odd users. Thank you. And we want them to sign on once, and that's it, and be done with it. So based on our needs, we ended up on DynamoDB for the low operational overhead, right? We didn't want to be on call for a database, or as little on call as possible for our database. You want me to test it? Oh, it just worked. Got it? Yep. Thank you very much. So we ended up on DynamoDB, right? So that's step 1 to getting to needing replication based on DynamoDB. Okay, this is a slight tangent, but I can't talk about signing on in an identity service in OpenID and users without talking about personally identifiable information. So the privacy of our users is incredibly important, and personally identifiable information as a concept is is legislated. Like, you cannot mess this up, or you can get in serious trouble with actual governmental bodies. And so this also plays into the cross-region replication needs, because now we have to not replicate things that are personally identifiable, and we have to replicate other things that we'll talk about through the rest of the presentation to help us deal with it. But that's what PII means when I say PII data. So, like I was just saying, PII data is one of the first contexts in which we actually first started talking about having to replicate data between regions. Which seems kind of weird, right? Because I just said you don't want to replicate PII data. But what that means is where we ended up is we have OpenID processes, right? This OpenID application that we're using to authenticate our users, and it's running in multiple Amazon regions. So say US East 1 and EU West 1, just as an example. So those applications need to be able to get user data regardless of where it actually lives. So if the user data is stored in US East 1, and you're accessing it from the application in EU West 1, somehow that application needs to know to actually get the data from US East 1, right? So the solution we came up with, and we'll talk about some of the benefits and drawbacks to this solution later, I think, but the solution we came up with are these pointers. So these pointers are PII free. There's nothing about them that's private or sensitive. So we can replicate these globally. Once we've replicated these globally, the application can always find it locally and then use that to look up the user's home region based on their user ID, and then map the home region to an Amazon data center and make the correct request to get the user's PII data. So we talked about this and we talked about the need. So the next thing we had to do was an intensive R&D figuring out how we're going to do this, right? We had this decision process. So I went to Google and I typed in DynamoDB cross-region replication, and I clicked the first link. And that was kind of the beginning of the R&D process, as one does. The first solution that I chose was, or the first solution that I clicked was the AWS CloudFormation template that they provided to you to do this. It's actually deprecated, so there's not too much reason for me to talk about it a lot. But it would spin up containers in ECS, and it would use those containers to do the replication for you. It would also do the initial copying of the table data. If you really mess with it, like deleting tables and stuff while it's working, you could get it into a bad state, and I had to get like Amazon reps to help me fix it. So we didn't go with that solution, even though it was not deprecated at the time we were evaluating it. So we kind of threw that one off into the rejection pile on the upper right. So I continued my research and I clicked the second link in the Google results, and that led me to the Kinesis client library, which Prahlad just talked about. And it also relies on the DynamoDB streams adapter. But we were this real small team. We did not want to adopt a lot of operational overhead. So as strong of a solution as this is, for us in particular, for our story, it was more than we wanted to take on, especially given that we were kind of already aware of Lambda being able to maybe do this. So some of the downsides of this solution for us in particular are the operational overhead of, like, you're responsible for the EC2 and the process that you wrote that embeds the library, right? And by being responsible for all that, if it fails for any reason whatsoever, you have to figure it out, your own call, stuff like that. You have to scale it too. So I don't think it was actually the third link in Google, but like I said, we were kind of aware of a Lambda, and we were thinking about how we're going to solve this, and it was just kind of putting two and two together, that hooking Lambda up to Dynamo Streams is really like a one-click thing in the console. It's very simple, right? It's all built for you. And so we just ran with it, and we said, let's try this and see what we can do with it. We've kind of touched Prahlad touched on these a little bit already, but just to reiterate, the actual updates that get stored in your DynamoDB stream persist for 24 hours. So if something explodes catastrophically, you do have a chance to react to it by getting things up and running and processing those backlogged records. And then there's some other stuff if it's important to your particular use case, like you can parallelize inside the Lambda function. You can break out threads and do things in parallel. And importantly for us, very low operational overhead. We are a Java shop. So if you're not a Java shop, you can kind of tune out for the next 20 seconds. If you are a Java shop, you may, and you're not using Log4j, last time I checked, Log4j is really the only official adapter that's available. So that was kind of a bummer because we use Logback, and so we had to have a second kind of extra, get familiar with the whole second logging framework. It also logs to Amazon CloudWatch, which is great if you're already using it. But we tend to aggregate our logs into an ELK cluster at Connected Fitness. And so this is like a second place where we have logs now to go check. So the third one is if you're used to runtime configuration, like 12-factor style, where you set environment variables. That's not really an option in Lambda. We kind of hacked around that by we would set alias names on our Lambda functions. And the alias name is actually a key into a set of configuration. So that was how we kind of like faked having environment variables for our Lambda functions. So we've talked about some background and how we ended up at this where we are now, right? We decided on Lambda, DynamoDB streams, replication via that. What has our experience been so far? Well, this is specific to us, but it's about leveraging the public nature of DynamoDB endpoints to deal with PII data, again, using those pointers. So this is just to make concrete all the things I've been talking about and how we implemented it at Under Armour. So for example, if you've got users using your application in EU West, right, kind of going down the right side of this diagram, the first call you need to make is to your local database, so the green line straight down, and you get that pointer. And that pointer says, hey, for whatever reason, this user's data is in US East 1. So then you can use that pointer and the fact that DynamoDB endpoints are public, right? They're just internet accessible, protected by TLS encryption and all the header signing that Amazon does via the SDK for you. And so you can use that fact to let your OpenID server in EU West 1 connect directly to US East 1 and get the PII data from where it's supposed to be stored. But for this to work, each application has to always have access to those pointers in its local database, right? So how does that work? Well, the opposite, the other side of the coin is the writes. So right now, we're running a single master topology for our anonymous data, or for our non-PII data. So what that means is all of our OpenID applications, when they need to write anonymous or non-PII data, they write it to US East 1. And then all the replication kicks in, and it gets replicated to EU West 1, as in this example, and then all the other regions that we have a presence in. Again, using the public nature of Dynamo endpoints, when you need to write PII data itself, you just write it directly to the correct location, based on the user's known home region. So in this case, we're writing it to EU West 1 directly. So this is where the replication comes in of that anonymous data to make those reads on the previous slide possible and to make the whole system kind of run off this replication so that we always know where to get your data. I'll actually touch on one more thing before I move on from this slide, which is there are other tables that benefit from replication that are anonymous data more than those pointers, right? So you can replicate refresh tokens, right? It's just another example. So I think we've got at least 5 or 6 tables that we replicate. So I included this slide because I thought it kind of captured the simplicity of the setup. So this is our Lambda function. It's actually Scala, even though I said we were a Java shop. But because Lambda, the Java version of Lambda is just JVM, you can run JVM languages. So in this case, we've got this Scala class. And the simplicity of it is that all you have to do is give Lambda a handler. And that handler is going to get past the event, which has all the data and the context. So like the first line inside the handler, I mentioned this already. From the context, you can get the Lambda alias. And that's where we're using that alias to look up our runtime configuration. And that runtime configuration tells us, for example, which regions to replicate to. The rest of this is pretty straightforward. We filter the records so we don't necessarily replicate everything, and then we just do it. Now, this slide is kind of abstract, but the gist of it is latency is bad. Like, right? Latency bad. And the thing about our setup is we've talked about PII data you're accessing potentially in different regions. That's going to be slow, right? There's this tax, there's this overhead, and whenever you make a call, say from EU West 1 to US East 1, or conversely, roughly there's a 50 millisecond tax in our experience. So that's real bad because latency affects the user experience. So this is one thing where like we've really got our eye on it and we want to do better. But it's unavoidable for PII. It's a little bit better for our anonymous data because we are replicating it for reads. It's not great for our anonymous data for writes if you're outside US East 1 because of that single master topology. All right, so I think roughly a year in production. I'm not super good with dates, but it's been super reliable. So other than the one time that I like totally on purpose set off the alarms as a test. It was not at all an accident. The alarms just haven't gone off. And it's enough to the point where it's like a little bit suspicious. You're like, is it even working because it's been quiet? So it's been really reliable, and that's been really pleasing, especially with the small team size. All right, so where do we want to take this next? Because like, especially with the latency slide, right? Like I kind of talked about, it could be better. So one of the ways we want to make it better is reliability. So if US East 1 goes down, which is highly unlikely and unfortunate if it does, but if it does, our applications become unavailable because we're unable to write that anonymous data, the non-PII data. We would like to fall back to EU West 1 or some other region even. Unfortunately, doing that implies a multi-master setup. It's no longer a single master topology, but that sometimes is just, like that's the price of having a more reliable application maybe. We use Hystrix internally in some of our apps, which is a library from Netflix. And so I just included this write column to make it really concrete, because Hystrix is like a circuit breaking library. It's really great. It also does load shedding and bulkheading. So this is just like the pretty cataclysmic scenario that US East 1 and EU West 1 are both unavailable at the same time. But by goodness, we're still up because we're going to fall all the way back to AP Northeast 1. Right, so that's the goal. That's kind of like the bar to hit, if at all possible, for reliability. And then back to latency, if we can allow you to always write that anonymous data to your local database, all those interactions the user has with the app that need to do that are going to be that much faster. So we want to squish this down and just improve the user experience. Again, relying on now a multi-master setup where you can accept writes anywhere. So when I talk about a multi-master setup that's also doing replication, write ordering should be kind of a big red flag, right? Because now you can theoretically accept writes into different regions at the same time. So you can get concurrent conflicting writes. So your system, if you go down this path, or if you're thinking about it, your system has to be able to deal with that. There's a ton of work on this. I'm actually going to try and touch on some of like the theoretical stuff at the very end. But for now, our solution is like simplicity as much as possible. Just simple, 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 right? So we're adding 3 attributes to our items, or 3 columns to our tables of timestamp, write ID, and replicate me. To use those 3 new attributes, it kind of goes through this state machine, right? Some of this state machine is not actually that interesting. On the left, that's just the OpenID application writing to Dynamo. So that's no big deal. Going from the DynamoWrite to the stream shard updated thing, that's all under the hood, right? That's DynamoDB streams. So you don't have to worry about that. Lambda pulling those streams is still under the hood. That's where you've told Lambda, hey, I want to consume the streams for this table. When you get to the 3rd column and the first decision diamond in this flowchart, that's where your actual Lambda function comes into play, right? That's your code. So we consume, this is the first of those new fields, right? So replicate me, that's just a way for the application to say, hey, this is a novel write into the system. So in our data layer in the application, we just pretty much consistently, we set replicate me to true all the time, right? And that way, all writes that come in from the app, from the OpenID server, need to be replicated. And then when we actually do the replication, we can set that flag to false, and you avoid the infinite loop of like constantly replicating back and forth. So in a decision diamond, to the right means false. So in this case, if we replicate me as false, we go to the right and we're done. Processing this event is over. If it's true, we go down into the replication box. Right? This little rectangle is like the magic. And the reason it's just a rectangle is there really isn't any magic. This replication is just using the Amazon SDK for DynamoDB. It's not like, there's really nothing else to it. You're just making a put item request. The one thing that we add to that makes it a little more complicated than just put item is we have a write condition attached. And I'm going to talk about what that write condition actually is, but to finish this flowchart, if the write condition fails, what that means is we're going to go to the write. I'm sorry. If the write condition has not failed, we go to the write and we're done. So write condition failed is false, which is great. That means replication succeeded. We replicated the update and the system is done. If the write condition did fail, if it's true, we go down, and that means that we had a write conflict. So we had concurrent writes for some reason coming into multiple regions, and now we've got this write in memory, and we've got to do something with it because we could not replicate it. So we put it in S3, and again, this is like very specific to us, right? This is our solution. Again, like simple, simple, simple. Just put it in S3 as an audit trail. We can hook up that data in S3 to things like our customer happiness tooling. So they can actually see for a given user that writes have been discarded. And that helps them triage when someone's having like issues with the application itself. So I said we talk about the write condition, and then this is it. This is not pseudocode. This is literally the string that you give to the Amazon SDK. This is the write condition. If you're not familiar with write conditions, I guess the thing to understand is that the symbols that are prefixed with colons will be interpolated in the Lambda function. So those are values that are coming from the update that we're trying to replicate. The symbols that are not prefixed with colons will be interpolated with the data in the document that is being replicated over. So the data in the document that is in the target region. So I said simple several times, and it really is, right? We're doing timestamp-based conflict resolution. It is literally like the simplest solution you can do. Some might even say naive, but I'll talk about why too in a sec. So to run through this though, right? The timestamp coming in has to be greater. So we just take the latest write, and that's what wins. If the timestamps for some reason are the same though, we want to cover all our corner cases. So we also include, this is that third field that we saw back on the previous slide. We include a write ID, which is just a UUID. It's a random 64-bit number represented alphanumerically. That's the tiebreaker if for whatever reason timestamps are the same. It is arbitrary, but it's consistent. And that's actually the key here, is this whole thing is designed to be consistent. The design constraint is we did not want, under any case, if at all possible, for replication to come to rest and have different data in different regions. Because that's just a nightmare for developers and customer happiness to debug when it actually becomes a problem. And it also means your data can just accumulate entropy. Because over time, some of those may not actually come up as problems right away, but you can sort of slowly accumulate these errors. So the whole thing is designed to end up with the same data everywhere. So again, to make things visual and concrete, I made some timelines. This is the happy path. This is a write coming into one region. It's really simple because there's no potential conflict. You just replicate everywhere. It may also be useful to note that in our setup, our multiple regions are unlikely to get concurrent writes, right? This is not a single data center multi-master database where you can potentially get conflicts per second because you're accepting writes frequently at multiple masters. Unless a user, for some reason, is GeoDNS or latency DNS routed to different regions in a short time frame, most of their writes are just going to go to one region. So most of the time, we're going to go down this happy path, and things just work really simply. But if somebody's doing curl requests to different regions or something's going on, again, we want to handle it, and we want to end up with a system with the same data everywhere. We do not want entropy. So this is an example of 3 concurrent writes to 3 regions and how those resolve. One thing to note is this slide is technically incorrect. Timestamp 2, when it replicates up to US East 1, should have succeeded. But in a sense, the end result is the same, so it kind of doesn't matter, which is the whole point. in the end, timestamp 3 should win everywhere. And so even if timestamp 2 had succeeded, if that was represented correctly, timestamp 3 would have still clobbered it. The timestamps are just epic milliseconds. They're not actually 1, 2, 3, but for the example. So timestamps could be the same. And again, we want to cover our corner cases because we don't want creeping entropy. So in this example, say timestamps are exactly the same for 2 updates that concurrently enter the system in 2 different regions. Well, we still have the write ID. And statistically, the write IDs are not going to collide in the lifetime of our universe. So we're going to count on that. And in this case, write ID B is alphanumerically greater than A. So it wins everywhere. So the final state of the data, is write ID B everywhere, which again is good. That's the whole goal of this design. But this solution works for us, and it meets our needs, and it meets our goals. But if you're on this path, or you're considering anything, if you're considering going down this path, or you're already on this path, there's always something to be learned from what if we started over, right? Started fresh with all the knowledge we have now, and like our newfound awareness, and actually paid attention to the theory from the beginning. So let's do that right now, in case that's valuable to somebody. I will admit, you are welcome. If you are familiar with distributed database design and you want to laugh at me for my naivety in this next bit, that is totally okay, because it was pretty bad, I admit. I spent a little bit of time trying to design a system that was, in a sense, immune to write conflicts. I thought, if I can just find the right something, right, the right magic, that I could set up this system that we'd never have to worry about write conflicts ever. That's not possible. So if you're thinking about that, you may be heading towards a pitfall. So if write conflicts are going to happen unconditionally, full stop, the only thing that's left to do is figure out what you're going to do about them. Right? So you can't avoid them. You must recognize and resolve them. And that's what we ended up doing. Our solution is very simple, but we recognize them and we resolve them via timestamp, and we're done with it. But if you're at a point where you have the opportunity to think about this problem from the beginning, and you can let it influence, say, your database design, right? Or your document schema, whether you're using Dynamo or anything else, what we can learn from the academic work around this and the best practices is that because when you have write conflicts, you have multiple versions of the truth. So think about how you're going to represent that. Can your data design handle multiple versions of reality? Because that's really what's going on in a multi-master system with conflicting writes, is that disagreement, right? So if you can design your system to do that, you're a step ahead. There are these things called CRDTs. That acronym actually stands for a couple different things. But one of the things it stands for is convergent replicated data types. That's kind of like the formal academic work on how to solve write conflicts in distributed systems. So that's one of those hooks, right? If you're thinking about going down this path, read about CRDTs a little, learn about them. They seem like magic sometimes because they talk about automatically handling write conflicts. They have downsides though. Some CRDTs, for example, will grow without bound in the presence of continued write conflicts. Unbounded growth of anything is usually a real bad problem waiting to happen. Yeah. So CRDTs, even though they're kind of academic, are actually not that intimidating either. I believe that if you actually looked at Under Armour's solution with timestamps, that you could make the argument that is a single, or like that is a single value register convergent replicated data type. I think that's like actually a thing, so we kind of accidentally reinvented it. Cool. But there's lots of them, lots to learn. I included this slide because a lot of the stuff I started from, just Googling with my intense like research and development style. But a lot of places, I often ended up on Bashow's blog, and I learned a lot of things there. So I wanted to include it here. And this is just kind of a screen grab from one of their more recent posts on dotted version vectors. And so dotted version vectors, just to keep throwing words out there for you to kind of hook off of, dotted version vectors are a way of establishing causality in your database, and they're part of making a CRDT. So like you may make a CRDT that uses dotted version vectors to not grow as much with outbound. But yeah, so I learned a lot from these people, and I'm by no means the expert, but so I wanted to give them credit. Russell Brown, I think, did a lot of the work of translating some of the academic papers into these blog posts, so that's why he's up here. Nuno, Carlos, Paulo, Victor, and Ricardo are the authors on this paper at the bottom, who again, they drove a lot of the work on dotted version vectors itself, which is kind of a new thing as of a few months ago, I think. So yeah, there's a big world out there to explore, but that's all I've got. Thank you, everybody, for being here. If you've got anything that you want to talk to me about or follow up on, whether, something you saw on my slides, just get in touch with me with my contact info. Thank you very much to the engineers who run the audio and video. Like, they make this really easy on the speakers, so that's it. Oh,